Okay, today we're going to work on some science. So this is your first science packet that you're doing for e-learning, and it is called Excellent Electricity. The term electricity is used to describe types of energy. Electricity is the movement of charged particles, usually called electrons, from one place to another. Electricity can occur naturally or can be created by humans. Static electricity is a type of electricity that occurs naturally. Have you ever taken clothes out of the dryer and noticed that they are stuck together? Or do you hear a crackling sound? This is static electricity. When clothes are rubbed together in the dryer, there is a buildup of charges and static electricity occurs. Dragging your feet across a carpeted floor can also create static electricity. If you felt a shock, it was most likely the movement of electrons from the carpet to your socks or static electricity. Electricity is also created by humans. Humans use electricity to generate power for lights, appliances, computers, and much more. When creating electricity, humans need to create a circuit or path for the electricity to follow. There are several kinds of circuits that can be created. A series circuit has only one path for a current to follow. You may have seen a tree decorated with lights made of a series circuit. If one light is burned out, all of the lights on the string are out. Because of this, series circuits are not always convenient to use. Therefore, a parallel circuit may be used for electricity. A parallel circuit has more than one path to follow. If part of the circuit or path is blocked, the current can take a different path. Parallel circuits are used in homes, schools, and businesses. By using parallel circuits, people are able to plug in devices and appliances and turn them on and off at different times. So we have some vocabulary words down here at the bottom. Okay, so these are in our glossary. It says charges, which is the amount of electricity which can either be positive or negative, and current, the flow of electricity. And over here, they give us a diagram. Okay, it shows us how a series circuit works. So in this series circuit, electric current flows from the battery, which is here at the top, to a wire, to a light bulb, to another wire, and back to the battery. So it goes in a circular fashion. That is a series circuit. If any piece of the device is removed, the current will be broken and the bulb will not be lit. So if we take this wire away, the light won't light up. If we take the battery away, the light won't light up. Okay, so let's look at the parallel circuit. In this parallel circuit, part of the path is missing, the other light bulb. However, the current is able to take another path and the light bulb is able to still work. So our path goes from the battery through the wire, and there's this first light bulb, okay? But there's also another wire here. So it can go here and connect to that light bulb, or it can go this way and connect to this light bulb to light it up. And then there's another line that goes to our battery. On the back, we have another article. It's called the Middletown Observer, May 17th, 2017, edition 429, your source for hometown news. So let's focus on this first one that says, Boy Creates Electromagnet. A student at Carter Elementary won the science fair with his electromagnet. Both magnets and electric charges can create forces that push or pull. Philip Franks used a coil of wire wrapped around an iron nail to make an electromagnet. Each end of the wire was connected to a battery. The nail then became a temporary magnet, and paper clips were pulled to it. Judges of the science fair were impressed because an iron nail is not typically a magnet. Because the nail had an electric current running through it, it became a magnet. Objects that were attracted to any typical magnet were then attracted to the nail. Over here on the side, they give us the weather for the weekend. So it tells us Saturday, thunderstorms arriving early in the morning and lasting all day with a high of 90 degrees. And Sunday, sunny skies all day with a high of 94 degrees. At the bottom, they give us something else to think about. It asks us, is your home safe? What you need to know about conductors and insulators. Electricity is the movement of charged particles from one place to another. People use electricity in their lives daily, but many do not realize electricity can be dangerous. Conductors are materials that electricity can move through easily. Metals, such as copper, are good conductors and are often used to carry electricity. Because metal is a good conductor, wires carrying electricity are made of different types of metal. The wires are often covered by materials such as plastic or rubber. Plastic and rubber are insulators. Insulators slow or resist the flow of electricity. If you see wires that are not covered by an insulator, they could be very dangerous to touch and may cause fires if not properly